Hello, welcome back to yet another episode of Learning with Junaid. Today we are going to talk about an interesting problem, that is how to find an n to a last element in a linked list. This is a very common problem that is asked in interviews. So basically they are going to give you a linked list. I already have a pre-populated linked list and we have to find the nth to the last element of the linked list. It's a little tricky question. I have a method. Currently it doesn't do anything, so we are going to write the method and understand the logic of how it is done. So basically what they want you to do is, if you have this linked list, so you see these nodes A, B, C, D, E, F, G, and they give you a number. For example, in our case, let's say they want to give you 3, so we need to be able to go and print 1, 2, 3. These are the last 3 nodes, so I should have E, F, G. That's my output. So how do we do that is what we will see today. So I wrote a method. It says find n to last element, that is 3 from the last 3 elements in a linked list. So how do we find out? Let's go ahead and write the logic. It's pretty simple. What you want to do is you want to maintain 2 counters. The first counter would start here and the second counter would start somewhere here, so that the distance between the first counter and the second counter is equal to 3. The way we do it is because in the second iteration, when the second counter moves through all its nodes, our first counter would start from here and come back all the way here. So a little tricky, but we can just go ahead and write it in a code and understand step by step how to do it. So we have a head. I'm going to take the head into a node called list1 is equal to head, and I'm going to do the same thing and say list2 is equal to head. So I maintain the head, or I maintain the linked list in 2 different variables. So the next thing is iterate through your one of the list. You can either take list1 or list2, both are pointing to head. I is less than n minus 1, I plus plus. And why do I take n minus 1, that is 3 minus 1, is because my first time my list, whatever list I'm working with, would come 1, 2, 3. It would stand at here, okay, and my other list would be here. So the difference between this and this would be 3. So that's what we want to maintain. We want to maintain the distance of 3 between this one and this one. So I'm going to go ahead and I'm going to make a check first. Let's say that I'm going to pick list2 equal to null. If it is null, then just return it. We don't have anything to work with. Otherwise, keep incrementing. List2 is equal to list2 dot next node. So now what will happen, I'm going to debug this program to just explain you a little better. The first time this iteration happens, my list2 would be standing at this place. This would be my L2, list2. Now what I do is, while my list2 dot next node is not equal to null, now from here I'm going to iterate all the way from here to here, here to here, here to here, here to here, and at the same time I'm going to have that first node. I will push the iterate the first node to point from here to here, here to here, and here to here, and it will come here. So by the time your list node will iterate, list2 dot next node is equal to next. By the time your second node, this node will iterate through everything. My first counter will walk all the way from here to here. So that's why we maintain a distance of 3 between this node and this node the first time. So that's why we had to do n minus 1. So now what you do is list 1 is equal to list 1 dot next node. So this would have exact node on which we have 3 or whatever was the number that was passed to me. Just go ahead and return this. I'm going to go ahead and debug this so that you guys understand what's happening. Uh-oh, something is not right. Oh, sorry, I think I made a mistake here. List 1 dot next node, sorry. I'm trying to understand why this was not working. So let's go ahead and debug it. Okay, so I'm going to go ahead. You see the first time you have list 2, and list 2 would be C. You see list 2 would be C and list 1 would be at A. So the difference between A and C is 3 nodes. That's a number that we are working on. Our assumption is when C moves all the way outside, this L2 moves all the way outside, our A would have moved to exactly the same number that we are looking for. That is, the first node would have moved at the same number. So let's go ahead. See, the first time it moved to B, the second time it moved to C. It keeps moving until it comes to E, which is the third element from the list. So let's go ahead, press it, you get E, F, G. One trick or one suggestion when you're working in a question like this in an interview is you can possibly also try to use recursion. That will make it a little complex, but always try to go for a most simpler way. The simpler way is maintain an exact distance between L1 and L2, which is nothing but n, and then iterate one of them until it has no next node. Then the other one, while you're iterating at the same time, go ahead and iterate the other one so that the node that you get here is exactly starting at the place that you want it to start at. So let's go ahead on this EFG. So if you want to go ahead and say I want to try from second node to the last, second to the last, from n to the last, find the second from the last element. And show until the last node. Now you do that, go ahead, run it again. You would have F and J. The idea of to do this would come with a lot of practice of what we need to do, but eventually I think if you can understand, if you maintain 2 counters, one for this and one for this, and maintain a distance, then every time this will iterate, you iterate the other one, so you come at the same point, then it would actually solve your problem. So if you like this video, if you have any comments, go ahead and please write a comment. Until then, next time, if you have not subscribed to my channel, please go ahead and subscribe to my channel. Until then, next time, we will see you soon. Thank you and have a nice day. Bye.